All right, I think that's pretty much everybody checked in at this point. Hello, everyone, and thank you for joining us for today's session. This is on type-based advanced ladder and Cscape 9.9 Service Pack 3. As usual, ask any questions throughout the session using the questions option in your control panel, and we'll answer those directly after the presentation.
Hi. Today we'll be doing an introduction to tag-based advanced ladder programming in Cscape Service Pack 3. We're going to start by comparing tag-based advanced logic with what many of you already know, register-based advanced logic. Then we will move on to the larger part of the video, which will be a tutorial in Cscape. We're going to go through variable handling, ladder creation, screen creation, and debugging. To finish, we're going to cover user-defined function blocks, although we do have another separate webinar fully explaining the topic. First, let's take a look at the different logic styles side by side. In Cscape, there is only one way to configure things, such as screen graphics, communications configuration, and hardware configuration. But we give our users a choice when it comes to their logic style. There are three languages built into Cscape that determine the logic style in which users create their programs. The first language created was RegisterBased Advanced Ladder. This is maintained being the most popular means of Cscape programming. A few years ago, we created another advanced ladder style, tag-based advanced logic, which we're going to be talking about today. The last language is not advanced ladder, but standardized IEC logic, which is very popular and offers the most amount of variety in terms of languages. Before we take a look at tag-based logic specifically, first let's take a look at the original register-based logic. The key feature of register-based programming is that it requires all variables, which we call I/O names in Cscape, to be mapped to a specific memory address. So when you add a variable, it must be mapped to a specific memory address. This is the style of logic that has been available since the first version of Cscape back in 1998, although there has been many enhancements since then. It is still the most widely used logic style in Cscape, and it is taught in our most recent Cscape training courses. However, there are some downsides towards using register-based logic. It is the most labor-intensive when it comes to replicating code, because of the addressing requirements. So if you have a section of code that you want to replicate, for example, code for a pump, if you have several you want to use, you can easily replicate the logic, but you have to manually readdress the newly replicated code. Also, for similar reasons like the addressing, register-based logic does not support user-defined function blocks. User-defined function blocks are very powerful tools that allow you to efficiently reuse sections of your code. So now let's contrast register-based logic with tag or variable-based logic. As a side note, we use the words tag and variable interchangeably when talking about the newer logic style. One of the advantages of tag-based logic is that you don't have to map out most of the variables to a specific memory location. In general, you create your variable names and Cscape will take care of them for you in the background. Tag-based logic has been available for several years, but recently we have made some enhancements that should overcome past limitations that may have prevented you from using this logic style. The tag-based approach is certainly considered the more modern approach. There are also several new enhancements being released that should promote the use of tag-based logic. First of all, we're eliminating the restriction on the number of registers, as with register-based logic, you're capped at 10,000 registers, but with tag-based, you can now use up to 50,000. So with the introduction of Service Pack 3, you'll have full memory access. You will also be able to make online programming changes, which is a method of making programming changes without stopping the controller. User-defined function blocks is a key feature that has been added in tag-based logic, which we already have a full webinar explaining. The last enhancement is one that will be very important for those of you who have lots of pre-existing register-based libraries, as we are introducing the ability to convert your register-based projects over to new tag-based versions. This enhancement will come with Service Pack 4, which will be coming in the near future. Okay, so now let's take a look side by side at some of the key differences between register-based and tag-based logic. So first, let's take a look at memory mapping. With register-based logic, as you can see in the graphic on the left, all the variables in yellow must be mapped by the user, and all the IO names in blue are optional. With tag-based logic, as you can see from the graphic on the right, you'll see the variable names highlighted in blue, with no reference to mapping, as it isn't required for most variables, although there are some exceptions. Variables that are tied to real-world I/O do need to be mapped. So if you have a digital input from a limit switch, it will be connected to a specific input and output terminal on the OCS or the I/O module, and those will require a specific memory address to be mapped to those variables. Another case in which variables must be mapped is when there are variables that are communicating over a network. For example, when you have a Modbus TCP client that is polling the OCS to grab some data using a Modbus TCP protocol. This is a memory mapped protocol, so therefore there will need to be mapping for the variables that are going to be polled by the Modbus client. The last exception is the case of indirect data moves, where data is moving from point A to point B directly, but you're using pointers from the source to the destination. So in general, in tag-based logic, you won't have to map variables, except in those cases. Next, we're going to take a look at the comparison in variable creation between our tag-based logic and register-based logic. In register-based programming, you can assign your I/O names and do your memory mapping as you go. For example, every time you add a contact or function block. To do this, you have to at least assign a memory address and for best practice, add an I/O name so that it's more readable and easier to follow the logic while you create it. In register-based programming, you also have the I/O names dialog that's used for editing, adding, deleting, copying, and pasting your variables. This is a tool to use to manage your variables. Next, we're going to take a look at tag-based programming. Similarly to register-based programming, you can add your variables as you go, but unlike in register-based programming, you don't have to map it to a specific memory address, at least in most cases, because Cscape will handle that part for you. In terms of managing your variables, in tag-based programming we don't have the I/O names dialog. Instead, we have a programming variables window. This is where we edit, add, and manage our variables when we're not creating our variables as we go. There are also features that incentivize our users to program with tag-based logic, one of which is structures. A structure is a meaningful group of data that can be used as a complex variable type. Taking a look at the graphic in the center of the screen, in the red box, I'm showing you the creation of a structure called motor control, that has 6 different elements in it, 3 of which are Boolean, start, stop, and fault, 2 of which are unsigned integers, restart time and RPM, and 1 is a real value, amps. These variables are all related, but can have different data types. After you create a structure, such as motor_control, you can use it as a type as you create new variables. If you look at the red box highlighted in yellow, you'll see main_motor with data type motor_control. So now, the variable main_motor has all the different elements of motor_control included in it. This is reflected on the graphic on the right. If we look at the first rung, you can see 3 highlighted elements: main_motor.start, main_motor.stop, and main_motor.fault. In the second rung, you can see that we're doing a calculation, calculating main_motor.amps, which is the real value. The bottom rung is showing one of the unsigned integers, main_motor.restart. So again, structures can be very useful, as they can be reused over and over again, and they can be used with both regular variables and array variables. So as you can see here, we have an arrayed variable, motor, of type motor_control, which is dimensioned 8 times, from motor sub 0 to motor sub 7. If you look to the graphic on the right, you can see when calling these arrayed variables, we use motor sub 3.start and motor sub 3.stop, referencing the 4th motor in the arrayed variable. Now we've come to the demonstration portion of today's tutorial. In this, we're running tag-based programming in Cscape 9.9 Service Pack 3, and we're going to go through variable handling, logic creation, screen creation, and debugging. Before we begin, To make sure that we can use tag-based programming, you need to go to Click Tools across the top, go down to Application Settings, and ensure that Advanced Ladder with Tags is checked as an option under Support Program Types. So to begin, I'm going to the top left of my screen, click File and New. I'm now presented with the option to choose between 3 different logic styles. Advanced Ladder Editor, which is register-based, IEC Editor, and Advanced Ladder Editor with Tags, which is what we will be using today. Okay, so I'm going to select it and hit OK. With register-based Advanced Ladder, we would usually manage our variables with the Program I/O names window, but in tag-based programming, we use the Program Variables window. If yours is not appearing like mine is, go here across the top of your screen to the Tools tab, scroll down and select the program's variables. You can pin it to wherever you want on the screen and resize it as you wish. So now, let's take a look at what we have as the default in our Program Variables window. First of all, we have 2 different types of category: global variables and retained variables. Both global and retained variables are accessible anywhere in the program, unlike how their names may suggest. Retained variables are variables that retain their value from their last power down, where global variables essentially always start at 0. There are no variables defined under retained variables yet, but under global variables there's a list of predefined variables. This predefined list is for things like real-world I/O, network global data, system bits, system registers, and function key type data. These are predefined but not really required and can be deleted. There are also array variables. AI, for example, is an array variable that has been dimensioned to 512, so it's from 0 to 511, and it's mapped to %AI1. So effectively, this is a default array of analog input levels that are mapped from AI1 to AI512. As we create variables, by default they will show up in global variables, but if you want them to be retained, you'll need to move them down under the retained variables heading. We also have some predefined structures in this window for PID and timers. So now that we've taken a look at program variables, let's start building some logic and see how it compares to when we create logic in register-based programming. I'm going to go ahead and build a simple start-stop circuit. So we'll first grab a normally open contact from here on the left and place it down, this creating a new rung. It's now prompting me to input a variable or address that I want to assign to this contact. If you remember, from register-based programming, we had to define the register location and, if we chose, an I/O name to go along with it. But here, we just have one choice. So we can either select a variable or just create a new one. So I'm going to do just that. I'm naming it start_PB for start push button and hitting OK. So straight away, Cscape recognizes that this is not an existing variable and asks if I want to create the variable, to which I'm going to say yes. This next tool that's popped up is one that's probably unfamiliar to you if you haven't used our tag-based editor before. This is where you define things such as the type of this new variable, if it's global or retained, or even part of a different user group, which is a system where you can group your variables together. You can also map your variable to a specific location through the attribute tag. For now though, this all looks good, so I'm going to say yes. And as you can see, the start PB variable that has been created has automatically appeared in my global variables tab in my program variables window. To continue, I'm going to go ahead and create a stop push button by placing a normally closed contact down on that same rung. I'm naming it stop_PB and I'm selecting OK. So it's Boolean and everything by default is fine. So I'm going to click yes, and as you can see, it's added itself to my program variables window. Next, I'm going to place a coil down and call it motor. So again, it allows me to create these as I go. The type is correct and everything looks good. So I click OK and I have motor created. Next, I have to provide a seal around the start button. To create this, I'm using two branches and a normally open contact. So in this case, motor is already created, so I could just start typing it in, and once it finds it, it will fill in the rest. The other method I could do is I could press this button here, which shows me all of the predefined variables which I can choose from. But from now, we'll just stick with the original typing it in approach. Okay, so now I've completed this simple start-stop wrong. Let's take a look at a couple of different scenarios. First, we'll look at a scenario where the stop push button is mapped to a real-world digital input. So let's say on the OCS that digital input number 5, %I5, is the physical input where the stop push button is going to be wired. So right now, the stop push button is being handled as an internal variable. There's no specific memory address tied to it, as Cscape is assigning something in the background. If I want this to be tied to the real-world input 5, I'm going to need to map it to a specific address to ensure that this variable comes from that specific input. So to do this, I'm going to go to my stop_pb variable in my program variables window, go across to the tag column and add in %I5. What this means is that when Cscape runs this program, it will look specifically to input number 5 for the stop push button. Even though this is tag-based programming, and you don't have to assign registers and memory locations for each variable, there are certainly scenarios where you do have to assign them. For example, in this case, with real-world I/O. Motor is another variable that will need to be mapped to a specific output. So let's say it's output 3 or Q3. So let's go to the motor variable and across to the tag column and add %Q3. So next, let's say start push button is a touch screen. To handle this, we have to go to our screen editor, which is accessed through this icon at the top of our screen. To begin, let's place a button on the screen, which we're going to use for our start push button. To configure, double click, and we're going to make it round and give it a 3D bezel. To name the button, select Legend, and we're going to name it Start. We're going to enlarge the font and to change the color. To do this, we have to go to our indicator properties. We're going to set the on color to light green and the off color to dark green. Okay, so we've defined this push button in every way except which variable it's tied to. So in this case, we want our button to be connected to our start push button variable. To do this, I can either start typing in the name or click this tool here and start to my list of variables. My start push button is set to a register width of 1 bit and everything else has already been predefined, so I'm going to select OK. So here's our start push button that's tied to our start_pb variable. It would also be very useful to know when the motor is running, so I'm going to grab an indicator from this icon up at the top left of my screen and place it down next to my push button. Next, I want to configure my indicator, and to do this again I double click and then select Legend. I'm naming it Motor Run and I'm going to enlarge the font a small bit. We're going to leave the colors alone, but also select 3D bezel again. When connecting to a variable, I can start typing it in or select it from my list of variables. So as I start typing motor, you can see that it auto-filled. And so we're finished and we can select OK. Now we're going back to our logic editor. The next step is to download the program to the controller. But to save time, I've done this already, so make sure that before you move on, that you've downloaded the program to the controller. Our earlier project has now been downloaded and is currently in run mode, but we want to debug it. To do this, click this debug icon across the top of the screen. As you can see, we have the availability of power flow on the stop push button, but none anywhere else. If we go to our start push button, it is controlled by the touch screen. So I'm going to go ahead and touch it. And you'll probably hear a beep. And now I've released the push button, and as you can see, the debugging works very well. Okay, That's just simple Boolean logic, creating variables as you program. Okay, so now let's take a look at timers. Timers are dealt with a little differently in tag-based ladder than they are in register-based, although it is very similar. To review, we know that timers and counters take up two consecutive words. The first word being the accumulator, for instance, what the elapsed time is, and the second word is what we call the housekeeping register. That's the one that we need to make sure we don't step on with the rest of our program. So how do we do that with tag-based logic? Because we really need two variables assigned to that timer or counter. In Cscape 9.9 SP3, we have added predefined structures, so within the program variables window we can see these. You can see we have some for PID and both timer counter 16 and timer counter 32. For this example, I'm going to use timer counter 16, which is a 16-bit timer. We need to right-click on global variable or retain variable, depending on if we want the value to be retained on power down or not. For this example, I'm going to use a global variable, and I'm going to call it motor timer. If I click under type and scroll down, you will see timer counter 16. So I'm going to click on this variable, and now I'm using it as a predefined structure of a 16-bit timer. I'm going to move my program variables window to make space to create a simple timer. So what we're going to do is set up a timer to time whenever the motor is running. So I'll create a new rung here, add in a normally open contact, and type in our variable motor. And as you can see, it autofills. Next, I'm going to grab a timer from here on the left and place it down on a new rung. For the timer of dress, I'm going to use this drop down and find our motor timer variable. So, our 100 millisecond resolution is fine. I could also assign a variable here to my preset, which I am going to do. So I'm going to select this button here, and I can start typing in my new variable, which I'm going to do and call timer preset. Next, it prompts me that timer preset does not exist, and would I like to create it as a new variable, which I'm going to select OK. So now it shows timer preset as an unsigned integer, which is the one that I want. If I want it to be retained, I can change the user group from global to retained. And I do, so I will. It's a non-dimensioned variable, so I'll leave the dimensions as they are. I don't need to map or tag it to a specific memory location, so I'm going to leave this section blank. So now everything is set, and we can click OK. So now I have my timer that's been assigned to motor timer, and my preset that's been assigned to timer preset. Okay, so now we're going to add this timer and this preset to the screen that we created earlier. So to enter, click this icon up along the top of our screen. Now that my screen view is popped up, I'm going to place down two data objects, one for my timer and one for my preset value. So let's make this one the preset value. It's going to be a 16-bit wide variable, and we're going to set it as a decimal format. We're setting our variable as the preset variable from this drop-down list. You may notice retained variables have a different icon which looks similarly to a disk. We're setting the format for 1234.1 because we plan on using decimals, as well as setting our text to motor timer preset. So we have our first data object for the preset, and instead of creating our second one from scratch, let's just copy, paste, and edit this one. So first, I'm going to change from timer preset to motor timer. The elapsed time will be in seconds, so our format won't change. This object is read-only, not read-write, so we're going to have to disable the edit write section. Lastly, we're going to set our legend text to elapsed time and hit OK. And OK. So we have added our preset value and our elapsed time. And to save time, I've already downloaded my program offline, so make sure you do that before continuing. As you make programming changes and want to test them, you have to download them to the controller. Before we can really test this, we need to make sure that there's a value under timer preset, as we made it editable on the screen. You won't be able to see me changing it, but I'm making it 15 seconds. Now, let's enter debugging mode, and we do this by clicking this icon up across the top of our screen. So as you can see, our preset is set to 15 seconds, and we're ready to test it. So I'm going to head and start the motor using the data watch window. And as you can see, we're timing and it's working fine. So we've covered Boolean logic and we've covered timers and counters. So that's our demonstration finished for today's tutorial. For those of you who may have missed our earlier webinar on UDFBs, here's a brief overview. Another powerful tool unique to tag-based ladder are user-defined function blocks. User-defined function blocks, or UDFBs, are ladder routines that can be modularized as a function block, where you assign inputs to the block and outputs to the block, and local variables used within the block. UDFBs allow your code to be efficiently replicated. So for example, you could create an application for controlling a pump, and if you had multiple pumps that are controlled the same way, you could replicate your logic across all the pumps through creating a pump control UDFB. UDFBs can also be OEM protected, meaning you can, if given permission, use UDFBs that were created by others through a black box. These UDFBs would otherwise be unavailable to you as they contain valuable logic or code that the creator does not want to share. This is created so that you can still use these UDFBs, but not be able to replicate the logic or code behind them. It is important to mention that support for UDFBs has not been available until the release of Cscape 9.9 Service Pack 3.
All right, we have a few questions in, not a whole lot today. First one here is, are variable names case sensitive, and which characters can be used for variable names? Variable names are not case sensitive, so two variables with differing cases are treated as the same variable. Characters used are numbers, letters, and underscore. When will Service Pack 4 be available with the Advanced Ladder Conversion utility? Service Pack 4 is at an advanced stage of testing, and I expect to have it released before the end of the month. Will you make available predefined structures? Possibly. We've added the two timer types and the PID type, and yeah, we may add more as we go along, but they're reasonably straightforward to add and save. Which brings me to the next question, which is, can the variables list be exported and reused? Yes, it can. At the moment, you do need to right-click within the variables window and edit IO names, I believe it is, and you can export them as an XML file, and then you can use the same facility in the variables window, right-click, and you can add the external file. It's saved as an XML file. Anything else? That's it today, folks. Not so many questions today. Once again, thanks for all of your time throughout this series of webinar sessions on Cscape 9.9 SP3. There'll be a short survey again directly after the presentation. We'd appreciate your feedback to help us make this better for you guys. We will speak to you again soon. Thank you.